Welcome to Young Timo Intellectual Educationalist channel. In our previous video, we discussed the introduction to variation. This video is the continuation of that video. Please, if you've not watched that video on introduction to variation, please download it and watch first before downloading this one. So today we will focus attention on examples on variation, but we will not be able to solve all the examples. We are going to focus attention on two examples, one on direct variation, while the second on inverse variation. Let's start with the first. The first example we are having here is on direct variation. This question says, P varies directly as the square of Q. If P equals to 36 and Q equals to 3, find P when Q equals to 10 and find Q when P equals to 100. Remember, when we discuss direct variation, we mentioned that if we say P varies directly as square of Q, that means P varies directly as the square of Q, that is Q squared. We learned that we have to remove proportionality sign and introduce a constant. So we now have P equals to KQ squared. So the set, if P equals to 36 and Q equals to 3, P equals to 36. Where we see P, we put 36. Equals to, where we see Q, we are going to put 3. So we now have K times 3 squared. So from here we have 36 equals to K times 9. Giving us 36 equals to 9K. So to find K, we are going to divide through by 9. So we now have K equals to 36 divided by 9. Then K equals to 4. So this K is a constant. In that case now, we are going to find the relationship between P and Q. So to find the relationship between P and Q, we'll come back to this expression. So we now have P equals to KQ squared. Now have P equals to 4Q squared. So this is the relationship between P and Q. Now, no matter any question they ask us to solve, we always start from that relationship. That is why it is important to first find the relationship. So the next question says, find P when Q equals to 10. So now, when Q equals to 10, when Q equals to 10, so we'll now be having P equals to 4 times, where we see Q, put 10, times 10 squared. So we now have P equals to 4 times 10 squared means 10 times 10. And 10 times 10 gives us 100. Therefore, P equals to 4 times 100 gives us 400. So that means when Q equals to 10, P equals to 400. Then the next one says, and find Q when P equals to 100. In such case, we come back to the relationship. Any question we are solving, we'll start from the relationship. So from the relationship now, we have P equals to 4Q squared. So when P equals to 100 now, P equals to 100. So we substitute 100 for P. We have 100 equals to 4Q squared. So we divide both sides by 4. So we now have Q squared equals to 100 divided by 4. So we have here, we have Q squared equals to 100 divided by 4 give us 25. Then here we now have the square, it becomes square root here. We now have Q equals to square root of 25. Then Q equals to 5. So what is our observation? From our observation, we discovered that when P is increasing, Q is increasing. And when P is decreasing, Q will also be decreasing. And that is the property of direct variation. We see here, when P equals to 36, we observe Q is 3. Then when P, so which means P is bigger than Q. Then when P now becomes 400, then what is our Q? 10. So as P is increasing, P increased from 336 to 400. Sorry, from 36 to 400. Then Q increased from 3 to 10. And then when P now reduced to 100, Q also reduced to 5. That is the property of direct variation. Now we want to consider the example for inverse variation. In inverse variation, remember in inverse variation, we said that when one is increasing, the other will be decreasing. An example we have here. The price of a material in the market varies inversely with the number of people demanding the material. When there are 80 people, the price of the material is 3 naira. What is the price when there are 30 people? So now we are talking about two things here: price of material and the number of people in the market. So let's represent the price of the material. Let's represent it by P. Then we represent the number of people by N. Then since they are inversely proportional, so we can now say P is inversely proportional to the number of people. That is 1 over N. This is property of inverse variation. So now we are going to remove proportionality sign. We now have P equals to K over N. So from the question, they said when there are 80 people, that is the number of people is 80. The price of the material is 3. So where we see P, price of the material, we put 3 equals to K over the number of people here is 80. So by the time we cross multiply, we now have K equals to 3 times 80. K will be equals to 240. So this is the constant. Then we go back to we have to find the relationship. So coming back here, we have P equals to K over N. Then P equals to K is what? 240 over N. So 240 is the constant in the variation. So we now have the next question says, what is the price when there are 30 people? The price when there are 30 people, that is number of people equals to 30. Then we now have, from here, we have P equals to 240 divided by number of people, which is 30. We have here 0 cancel 0. Then we can now say that P equals to 3 goes in 24, give us 8. So that means there are 8. The price will now be, when it is 30 people, the price will be 8 naira. So we now put P equals to 8 naira and no kobo. Please, anytime you are dealing with money, always involve naira and kobo. So that is the solution. What is our observation here? When we observe when P is 3, the number of people is 80. Then what now happen? When the number of people now reduce from 80, the number of people reduce to 30. What now happen to the price? The price is 80. So which means when one is increasing, the other will be decreasing. That is the property of inverse variation. So that is all we could do today. In our next video, we are going to solve example on joint variation. Please subscribe and follow the link so that you'll be able to get notification when the next video is uploaded. Thank you.